Good morning, everyone. I promise the scooter makes this injury look a lot worse than it is. It's just my pinky toe, but I got to stay off of it. So if you see me rolling around, just say hi. Well, next up, we have retired Brigadier General Dr. Pete Worden, who is a prominent figure in space science and exploration, currently serving as the chairman of the Breakthrough Prize Foundation and executive director of its breakthrough initiatives, which focus on searching for extraterrestrial intelligence. Previously, he was director of NASA Ames Research Center and has held various roles within the United States Air Force. With over 150 scientific papers to his name and a background that includes a PhD in astronomy from the University of Arizona, Dr. Worden is a respected authority in the field. He continues to push the boundaries of space exploration, exploring the possibilities of life beyond Earth and advancing the private sector space initiatives. Everybody, welcome Dr. Pete Worden.
Thank you. It's nice to be back addressing the Mars Society. I think it was about 5 years ago that I think it was in Denver where I first addressed the Mars Society. I too am medically challenged, but just by old age. So, again, it's really great to be here. It's great to be back in Seattle. One of the key things I want to talk about today is not just our foundation's efforts, but also the general question of life in the universe, and maybe follow on a little bit of what Dr. Zubrin's discussed about life on Mars. But I'd like to start with my sort of ultimate inspiration, which is Arthur C. Clarke. And this is a picture a long time ago. I think it was in 1999 in Sri Lanka. And Clarke was one of my heroes and a key mentor. I was privileged to get to know him early on online. I learned how to use the internet mostly to talk to him. But I had the privilege of meeting him in Sri Lanka and spending a few weeks there in the late 90s. But one of the things he has done is really inspire, I think, humanity with the idea that we have an unlimited future in space. And he also wrote a lot about key questions of intelligent life and life elsewhere. And I have one of his key quotes, which I think is really cool. He says there's two possibilities that exist. Either we're alone in the universe or we're not. And both are equally terrifying. So I think this is really probably kind of a key idea that the Mars Society is all about, that whether we're alone or not, we are alive, and we have a responsibility and an opportunity to expand, I think, initially into our solar system and then beyond. And I'll talk a little bit about what our foundation is doing. We started the Breakthrough Initiatives in 2015, and it grew out of the Breakthrough Prize Foundation. I won't say a lot about the Breakthrough Prize Foundation, but other than saying that we give the world's largest prizes in science. There's 7 $3 million US prizes for fundamental physics, mathematics, and life sciences. I should mention this is about 3 times the size of some Swedish prize I'm not going to talk about anymore. These prizes are given annually at what we kind of call the Oscars of Science. The first time you'll see, college professors in tuxes, but it's a pretty cool ceremony. But in 2015, the founder of the Breakthrough Prizes, Yuri Milner, said, look, I want to not just reward science to encourage the next generation, but do science. So he started the Breakthrough Initiatives, which were designed to address the questions of life in the universe. And there are 3 key questions, and I'm only going to talk about 2 of them today. The largest program I'm not going to talk about. It's the search for extraterrestrial intelligence. We've now call it technosignatures. This is a program funded at close to 150 million over 15 years. It has been moved, its headquarters from the University of California at Berkeley to Oxford University in the UK. We have an annual conference there. The next one will be probably in July of 2025. But one of the key questions and this is sort of addressed to this group, is where do we go beyond Mars? And a lot of the program is focused on the next nearest star system. the Alpha Centauri star system. So I'm going to kind of talk about, if people laugh at you're talking about going to Mars, they really begin to question that we're going to go to Alpha Centauri. Alpha Centauri, I think, is much more interesting than our solar system. There's 3 stars there, not just one boring star. 2 of them are about the size of the sun. They orbit around each other every 80 years. The 3rd one is a red dwarf star that's pretty far away. It has a several 100,000-year orbit at many thousands of astronomical units, but it's a red dwarf star. The interesting thing about the red dwarf star is that it's one of the most common stars in the galaxy. 70% are red dwarfs. But it's sort of statistically interesting that 2 of the 3 most nearest stars are actually solar type. Solar type stars are a little more rare in the galaxy. So we're very interested in studying these. And when we started, there were no planets known in the Alpha Centauri system. In fact, there were people that claim that planets don't form in binary star systems. And like a lot of things astronomers claim, it was rubbish. We started a program in 2016 called Breakthrough Watch. In 2016, right after we announced this, the European Southern Observatory announced the detection of 2 planets orbiting Proxima Centauri, the red dwarf star, one of which seemed to be Earth-size in the habitable zone, which was really cool. They were nice enough to invite me to the press conference when they announced this. We were nice enough to give them $5 million. You can always buy your way into a press conference. But we started a major program to study this system. A few years later, using the European Southern Observatory's extremely large telescope, or very large telescope, we detected tentatively a giant planet orbiting in the habitable zone of Alpha Centauri A. Those of you who are science fiction geeks like me will recognize that's the scenario in Avatar. So we're continuing to try to validate that. This is an artist's conception of the picture of what it looks like on the planetary surface. Now, I showed this to the billionaire that funds us, and he said, well, we don't need to go there now if we know what it looks like. So be careful what you show billionaires. Anyway, we have no idea what the planet looks like. But I will tell you, about 4 years ago, our other program, the Breakthrough Listen program, tentatively detected a technosignature, what appeared to be from this star system. Now, we're now convinced that it was interference, but I was really excited. When the principal investigator called me, I drank a whole bottle of champagne and was about to start on the second one. And he called me back and said, well, look, it's probably a interference, which we concluded it really was, but very interesting star system. As I said, we use the Very Large Telescope in Chile to find this tentative giant planet orbiting Alpha Centauri A. We now have a number of programs I'm not going to go into to confirm the presence of that giant planet and begin to see if we can find maybe Earth-sized planets. Now, I have a kind of a note here I have to note about astronomers naming telescopes. As I said, this is the Very Large Telescope, VLT. They're building a new one called the Extremely Large Telescope, which is like 39 meters in diameter. And kid you not, the initial name for this, because it was going to be 80 meters, was called the Overwhelmingly Large Telescope. So if you're better at naming, come and see the astronomers. One of the telescopes we're using is called the Large Binocular Telescope, the LBT. So again, I'm embarrassed that we can't think of cooler names, some Greek god or something. And again, as I said, the neat thing about this came from Avatar, that the scenario that is in Avatar is there's a giant planet orbiting in the habitable zone of Alpha Centauri A, and it has a moon that is not only habitable but inhabited. So it's kind of a neat scenario. Because of this, our sponsor got in touch with James Cameron in the hopes of him putting money into it. He didn't put money into it, but he did talk at our annual conference. The other program we had, which we put on hold, but it'll probably get restarted, is Breakthrough Starshot. Is can we send a probe interstellar distances to actually fly by these planets and see what's there? The idea was these are laser-driven light sails The spacecraft is a few grams. It's driven by 100 gigawatt plus laser that's on the ground to 20% light speed. We've made great progress, although we're probably still something that's in the second half of the century. I'm happy to talk more about that later. But let me talk about what we might do here. And this gets into some of the philosophy. This is George Church, who probably a lot of you know, sort of a leading geneticist. We had a conference a few years ago at Harvard, and he said, look, just taking pictures of planets in the Alpha Centauri system is interesting, but eventually he believes we have technology on the horizon where we could actually plant life in planets potentially in the Alpha Centauri system and others using some of this technology. Now, this is a big ethical question, and I'm going to talk a little more about this before I finish, is what if there's life there already? But I think the thing to understand is that, first of all, we don't know where life came from on Earth, although, it probably developed here, but it could have been planted from elsewhere, either through natural processes or even deliberate ones. By the way, I always like this picture of George because it reminds me of the pictures my mother showed me when I was a kid of what God looked like. George has that right demeanor. Now, there was an issue of astrobiology about a year ago that I was an editor on, and I and two of my colleagues, Paul Davies of Arizona State and Chris McKay of Ames, said, can we figure out how we might do panspermia without, some new technology by putting life on other planets? So we came up with the idea that there are these interstellar asteroids that we've now discovered a couple of. This is an artist's conception of Oumuamua. They're probably heavily made of ices that we felt, could you build an inoculum, something that's tailored to boot up life, implant them deep inside this asteroid so they could survive for hundreds of thousands or millions of years, divert the asteroid slightly so it flies close to, say, the Alpha Centauri star system. And as it gets in that star system, the ice melts as it would as a comet and releases the inoculum. And so this is a way, again, that we could boot up life in places that it might not be. Now, I'd like to kind of close by returning to the solar system. And with some trepidation, I show the picture of this object. And it's probably not one that Mars conference people like to see. This is Venus, Earth's evil twin. Over the last 4 or 5 years, there's been a variety of controversial detection of potential biosignatures in the upper atmosphere of Venus. The interesting thing in the upper atmosphere of Venus is that the temperature and pressure is about what it is in this room, although you happen to be in the middle of pretty pure sulfuric acid clouds. So it's kind of like what the Earth will look like in a few hundred years if we're not careful. But there is evidence of phosphine and more recently ammonia, both things that could be biosignatures but are highly controversial. The only way to figure that out is go there. There's a privately funded mission that the Breakthrough Initiatives has started to fund, as well as now Schmidt Sciences. Most of the effort is Rocket Lab in New Zealand. Hopefully this will go next year and we'll drop a probe into the Venusian atmosphere that can determine whether there's life there or not. My favorite place for life to look for as well as to settle is actually Ceres. That's another point we can argue about why Ceres, other than the fact that it was the headquarters of the Outer Planet Alliance in the expanse. But let me turn now to your favorite object, Mars, and just a few thoughts on Mars, which kind of come from some of the work that we've done in the Breakthrough Initiatives. Of course, one of the ideas is you actually build dome cities. The interesting thing is the UAE is actually putting a lot of money, and they want to, within a century, put a settlement. They're building a prototype in the desert in the United Arab Emirates. So I think this is a serious question again of that how do we get settlements and who's going to pay for it? But as Bob Zubrin mentioned, one of the key questions is where do you go in the long term? And this opens a long-standing discussion and debate, which I think is as controversial as panspermia, is terraforming Mars. Now, I'm not going to go through a lot of the discussions. but there's a variety of ideas, and this has begun to be very seriously looked at. In the last 6 months alone, there were two major workshops. One was in Pasadena a few months ago about terraforming Mars. Another one was a astrobiology, synthetic biology conference at Harvard University about a month and a half ago. And these are sort of looking at varieties of ways that you could warm up the planet, potentially releasing the carbon dioxide and actually forcing a runaway greenhouse effect that would warm the planet. Another way that's been suggested is using what we used to call when I was in the military, physics packages, big ones. The trouble is, if you look at the calculations, how many physics packages you need, it becomes a ridiculously large number that's much larger than the global arsenals, and it probably isn't a reasonable way to do it. But again, there's the thoughts that you would melt the polar caps with physics packages. One of the things that I find quite interesting is the idea of locally terraforming things. And again, I'm not going to go into a lot of discussion, but there was a major experiment, which some count as a big success and some count as a big failure, in Arizona, the Biosphere 2, that where you begin to sort of, can you create a local environment for Earth life? And I think this is a promising effort to really look at. And one of the tools you might use is biology, particularly synthetic biology, where you can tailor Earth life that not only can survive in these environments, but could themselves produce Earth-like environments to terraform. I note this particular paper, which is fairly recent. Robin Wordsworth is the organizer of the conference at Harvard a few months ago. And so his point is you could do this at micro scales, that you actually create a solid state greenhouse effect with pockets of warming under CO2 infused Martian ice, using various biology and synthetic biology elements. At this conference we had in Pasadena, one of the ideas is said, can we take life forms on Earth that already do some of the things you're interested in? This is and I'm not a, since I can't name telescopes very well, I certainly can't pronounce the names of these phytoplankton. I think it's a coccolithospore. But this is a plankton that actually builds little calcium shells. But one of the ideas is we could probably modify these so that the shell actually is a light focusing element that focus energy and heat, that you could create things that might live on Mars. Already there's bioleaching for mining on the Earth of platinum group metals and others. There's a number of efforts looking at, can we use bioleaching on the Moon and Mars to extract elements so you don't need to have complicated processes on Earth. This is one I think you're going to see a lot of effort on. The potential of actually tailoring biology to allow you to live on another world, I think, is a major effort. When I was the director of NASA Ames, we started a NASA effort in synthetic biology, which looks quite promising. And I think this is one that there's a variety of groups that are very interested in this, including the German equivalent of DARPA, Sprint, which is going to have a conference here later this year on the use of synthetic biology and mining, both on Earth and in space. Now, I'm going to close with just one question here about what if there's life on Mars, which I suspect there is. I love this picture. It said something else at first, but it was a little politically incorrect. But there's an idea that I just like to leave with you, that, and this may be complete rubbish, but the origin on life on Earth, that complex organisms are what are called eukaryotes. And eukaryotes are what we're made of. And inside every eukaryote is are organelles that these are like the photosynthetic organisms, but they were actually believed to be separate organisms. So sometime, roughly 1 billion years ago, the Earth was inhabited by two kinds of microbes. They're both called prokaryotes. They're very simple genomes. that was bacteria and archaea. And at some point, archaea supposedly sort of engulfed and created a symbiosis. So one of the questions that I want to leave with you is, supposing there's some sort of life form on Mars, perhaps we can artificially create the equivalent of eukaryotes, where you can create organelles that are inside Earth cells that are more have evolved for billions of years to be attuned to the Martian environment, or you can synthetically do them. Well, let me stop there, and I'm happy to answer a few questions. I don't know if we've got a few minutes or not, but these are just thoughts from somebody who's looking for life in the universe. Thank you. Yep.
Maybe too detailed a question, but when you mentioned bioleaching, I was thinking of the perchlorates and Mars' surface,
Yep.
which are rather problematic in the aspects. Do you know if any studies have been done whether bioleaching might help remove those so one can get growing soil that's not toxic?
It's an area we talked about, the idea of using, you know, I mean, there are archaea on Earth that are in places like the Atacama Desert that actually metabolize using a chlorine cycle, including perchlorates. I mean, those areas like that, there's actually a higher percentage of perchlorates than nitrates. So there's already organisms on Earth that can metabolize those. So I think there's a lot of promise in the idea of deperchlorating some of the Martian regolith. You know, one of my big criticisms of the movie The Martian is they're growing potatoes in perchlorate-rich soil. Perchlorates are highly toxic to most human life. So I think using biological ways is actually a very great promise. One of the things I mentioned, that if there was Martian life there, obviously it's probably uses, you know, these cycles, or could use those cycles. That's why you might be able to create a hybrid cell. So I think that's a very promising effort. I don't know of any specific studies that look at it, but it's an area I know that at least at some of these meetings over beers we talk about. But it's a great idea. Yeah.
Thanks, General. Oh, hi. So I took some of those thoughts in trying to catch the interstellar visitor.
Yeah.
Is that worth prioritizing versus maybe being prepared better for the next one in hopes that could happen?
Well, the question of these interstellar asteroids, I mean, there are now systems that can detect those. The best one will be the new the Large Synoptic Survey Telescope, the Rubin telescope. So we ought to be able to find quite a few of them. I mean, we know of 2 or 3 bigger ones. We also, it appears that there were 2 small sort of, you know, meteorite events that are interstellar. One of them, Professor Avi Loeb went out and picked up a bunch of modules on the bottom of the ocean, which probably were from those asteroids. I mean, he carries it a little further and says, "Oh, it's alien starship metal." Maybe that would be low on my likelihood list, but it's still a possibility. So I think that, especially with the Rubin telescope, we should be able to find a lot of these things. The idea that you would find one that was kind of in the right direction, that was an icy body, and then you could push it slightly through various means, like using a physics package. But you know, I think one of the key things, we need to have a lot of discussion about the ethics of these things. You know, and it raises the issue: was our life here on Earth planted? Is it appropriate to do that elsewhere? And I think that goes back to the first thing, the question that Arthur C. Clarke posed is, you know, if we really think we're alone, then maybe we have a responsibility to the universe that produced us to spread. You know, I think one of the other philosophical questions is, Schrödinger talked about what is life. It's still the best book ever written in 1944, and he suggested that life is the universe's answer to entropy, but he recanted that later. But I think that these whole questions, that this is something that this century we can do. We should figure out, should we do it and how we do it. But, yeah.
What are your thoughts on TRAPPIST?
The TRAPPIST system?
TRAPPIST. TRAPPIST system, for those of you that is a system that has, I think, 5 terrestrial-sized planets, 1 or 2 in the habitable zone. This is an interesting question. It's a red dwarf star, and there have been a number of observations made on them, including with the James Webb, that show that at least one of the terrestrial-sized planets in the habitable zone doesn't appear to have an atmosphere. And one of the key questions on this, and this is we could spend about an hour and a half on this, is that red dwarf stars most of them are active. They have flares and things. And a planet in the habitable zone has a period of 5-10 days. It's pretty close to the star, a few million kilometers by, a couple 100 million kilometers. And the flares on these red dwarf stars are the same size as solar flares. And they can be, 1 million times more energy than the star. The question is, will these sweep away the atmosphere? And after billions of years, right now, the only observations we have tend to suggest yes. However, there's a number of ways to stabilize that. One of them is if there's a strong magnetic field on the planet, it can, just like the Earth's magnetic field protects it. The other thing, in some cases, look at Venus. Venus would certainly benefit from sweeping 98% of the atmosphere away, if from at least a terrestrial or a human perspective. So I think the jury is still out on whether these things could have Earth-type life and so on. For that reason, at least initially, we're trying to focus on solar-type stars, of which there's about a dozen within a few parsecs. Although there's about 30 red dwarf stars, so that's a very interesting open question. I think TRAPPIST is probably uninhabited by life as we know it, but that doesn't mean there can't be something else that arises.
Since you worked at NASA for a while, I was wondering what your thoughts were on NASA's plans with respect to the moon and Mars, specifically human exploration of the moon and Mars.
That's another interesting question. I'm sort of known or despised, depending on your view, is I made a statement about 30 years ago that NASA was a self-licking ice cream cone. And I guess I get credit for inventing that. It was actually my father's World War II term. But my point was that NASA seemed to be a circular process that was self-justifying and didn't really want to do new things. One reason I went to work for NASA is Mike Griffin was one of my best friends when he became administrator. And he said, stop criticizing and come help us fix it. And I think that, the current NASA is not your grandparents' NASA. There's still some problems, but to my mind, what they're looking at, trying to use the private sector, to me, one of the most promising things is the CLPS, the Commercial Lunar Payload Services, that they have yet to be fully successful. But this is to allow you to commercially put for 100 million or so, reasonable payload on the lunar surface. One of the things my foundation is looking at is putting a radio telescope on the far side of the moon, a small one that you could survey the whole sky because it's not interfered with by terrestrial sources to look for alien technosignatures. So I think NASA is now kind of part of the solution, not part of the problem. And so I have mostly nice things to say about them, but not all. But I think it's very promising. So things that what this group wants to do, NASA's going to help.
Okay.
Okay, thank you.
Thank you so much.